Question 5. Howard chooses n different numbers from this list, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, so that no two of his choices add up to a square. What is the largest possible of n? So that what's the largest possible of numbers you can choose from this list so that you don't have any square numbers within that list. So can you take 2, 3, and 4, and then there's no square number in there? In fact, you can, because you add those up, you don't get a square number there. Let's see where we get to. So we start by looking at the pairs. The smallest pairing is going to be 2 plus 5, and the largest pairing is going to be 10 add 11, which is 21. Then I look at the square numbers between 5 and 21, and actually there are only two, 9 and 16. If we look at the pairs of listed numbers that sum to 9 or 16, we're looking at 2, 7, 3, 6, 4, 5, and also 5, 11, 6, 10, and 7, 9. In each pairing, you'll notice, and this is the key, if you like, to this question, that you've got 5, 6, 7 here, and you've got 5, 6, 7 here. So if you've got the number 5, the number 6, or the number 7, you're going to have a pairing with at least one other number. So if you don't choose 5, 6, or 7, we can have every other pairing. So we will eliminate any pairing to a square number. So if we cross those out, we've got the possible numbers 2, 3, 4, 8, 9, 10, and 11, and therefore we have 7 numbers. N can be a maximum of 7.